So this is our Assignment 5 for artificially intelligent. Here's our traffic. Here we use convolutional neural networks to predict the images, whether it's like one of our models. Here in our load data function, it gets data direction. In our case, it's this folder which contains subdirections like 0 to 42, like 40, overall 43 categories of signs, road signs, and it checks for every direction. And if not, if you don't have that path in our direction direction, it continues. And for if we have that direction, it checks for every file. Like in the case of 0, it checks this file and this file, and it gets a file path for that image file, which can joins the category direction and file name, and we read the file using that file path. And if our image is corrupted, we continue skip it, and we resize it in using CV2 library. It all image becomes 30 to 30. Here's we gave that there, and we need the same width and same length for our neural networks to train, and we normalize the pixels values to grayscale. It was like RGB format, and we turn it to black white, and we append that image and category to our returns tuples. And here's our get model. We use TensorFlow sequential, basically one after another. And our input layer is the images, like image weights and heights of 3 for RGB. And our first hidden layer, convolutional, we have like 32 filters, and each filter has 3 to 3 window, and we use activation function relu, which passes every minus values to 0, and if our value is higher than 0, we pass that value. And pooling, it reduces the size. It was like 30 to 30, and it becomes 50-50, 15-50. And we reduce it by so we can get only important features. Here is the second convolutional layer, and our pooling, it basically 64 filters. It detects important features like patterns, like shapes, and like triangle, circle. And in here uh, we also deduce our pooling size and flatten and dense layers. Dense is our it's like completed by adding those two convolutional layers. And here we drop out the randomly picked 50% of our neurons. So why we need it? So our model will not be overfitted. And layers, dense layer, it's like output layer. Here we return like 43 sized probabilities for each image to be that in that model. Like yeah, model compile, we compile it with optimizer item and matrix. We show the accuracy here from our we run its Python traffic model. We save the trained model into our file here, model H5. It trains like epoch. We gave 10 epoch. It's enough. And here we can see the accuracy step by step. Sequentially, it grows, and the loss function minimizes our accuracy, increases 31, 64, and so on. And our final result is here 98. And I also created myself another function called uh, predict image. It gets a model and image path and checks for which model, our image will be basically here in the main function. I just call that prediction model, our saved model h5, and the path to that image. For example, I took 14th, this image from 14th folder, and he predicted like 14, like correct version. And the second part of our fifth assignment, we have like terminals and non-terminals. Here's our adjectives, adverbs, conjunctives, and deterministic, yeah, nouns and verbs. Here are how non-terminals. It's basically the combination of these values. The sentence can be done with noun phrase and verb phrase, and noun phrase in its case can be done with just a noun like home, I, deterministic, determine, noun, is basically an, an armchair, like the combination of that and an, and deterministic app, it's adjective, phrase, and noun like uh, air, red, armchair. These phrases could be in our sentences, so we determine here in the non-terminals. Verb phrase can be only like verb or verb, noun phrase, arrived, armchair, I arrived, so on. Here's our grammar main. In here we have the pre-process sentence. We use NLTK word tokenizer for each word. We get that, and NP chunk, it's like subtree here. If you run it, uh, here for example, one sentence, yeah. I had a counter walk on Thursday and came home in a dreadful mess. It parses a whole sentence, like whole sentence gives whether it's noun and continues here the sentence and verb phrase sentence. Our main sentence here contained is summed up with sentence and verb phrase. Like in our non-terminals here, sentence can be done with s and conjunctional verb phrase here's and until. Uh, I, it's a noun. It can be an also noun phrase. Here's a sentence combined with noun and verb phrase. Here, verb phrase and noun phrase. Had a country walk on Thursday. Thursday is our noun, which is noun phrase. And on is our prepositional, and prepositional phrase is on Thursday. So on, so on. It gets three using NLTK chunks. We append that nested whole sentence. Here, another example. Let's sentence 10 txt. Here I had a little noise, red paint. It's an adjective phrase. So let's check another one txt. It's the simplest. It's like noun and verb. Like all the sentence can be parsed.